I'm going to show that 25 is a strong pseudoprime base 7. A composite positive integer n that passes Miller's test to the base b is called a strong pseudoprime to base b. So in this case, we have to show that 25 is composite and then go on and show that 25 passes Miller's test base 7. So for Miller's test, if n is a positive integer and if n minus 1 is equals to 2 to the power s times t, where s is a non-negative integer and t is an odd positive integer, we say that n passes Miller's test for base b if either b to the power t is congruent to 1 mod n, or b to the power 2 to the power j times t is congruent to minus 1 mod n for some j which is between 0 and s minus 1. So those are the two conditions there that we need to check. So I'll start by the first one there. We are having our n is equals to 25. When we factorize that, we have 25 is equals to 5 times 5, a product of two prime numbers. So we can conclude that the 25 there is composite. So it has passed this first step. We now go on and check if it passes Miller's test. So for Miller's test, we look at this part here, n minus 1. Our n is 25, so we'll be having n minus 1 is equals to 24. And then factor out the 2's there. So it will be 2 to the power 2 to the power 2 times 3, because 24 is 8 times 3. So we'd have 2 to the power 3 times 3. And then by comparing with this part here, we see that our s there, and the power to which the 2 is raised to the power 3, so we'd have s is equals to 3. And our t is equals to 3. And we are saying there t is an odd positive integer, of which 3 there is an odd positive integer. And our base b is equals to 7. We go on and check the first one there. If b to the power t is congruent to 1 mod n, substitute the values of the b, the t, and the n that we have, and then we have that 7 to the power 3 is congruent to 1 mod 25. If you still recall, we say that a is congruent to b mod m if m divides a minus b. So we can use this information to check if 7 to the power 3 is congruent to 1 mod 25. Now 7 to the power 3, that's 343. So we are checking if 25 divides 343 minus 1. 343 minus 1 gives us a 342. 25 does not divide 342. So we say that this one does not divide. So if it does not divide, then this congruence there is not true. So we are saying that 7 to the power 3 is not congruent to 1 mod 25. So this condition here has been violated. So we try to check if this one is satisfied. So we go on to the second step there, checking if this one is satisfied. So we are having our s there is a 3. So we'll be looking for some j which is between 0 and 3 minus 1. S minus 1 which is a 2. So we are saying that our j there is between 0 and 2. So we'd have j equals to 0, 1, or 2. Then we substitute our values into this congruence here. So we start with j equals to 0. For j equals to 0, what we would have there is 7 to the power 2 to the power 0 to the power 3 congruent to minus 1 mod 25. We need to check if this is true. 2 to the power 0 is a 1, so we'll be remaining with 7 to the power 3. 7 to the power 3, which is 343. So what we are checking there is 343 congruent to minus 1 mod 25. And we say that A is congruent to B mod M if M is A minus B. So in this case, we are checking if 25 divides 343 minus 1. 343 minus 1 gives us 343 plus 1, which is 344, of which 25 does not divide 344. So we cross it out, it does not divide there. So if it does not divide, that means this congruence here is not true. So if it is not true, so this one here is not satisfied for j equals to 0. So you can go on and try for j equals to 1. So for j equals to 1, what we would have there is 7 to the power 2 to the power 1 multiplied by 3 congruent to minus 1 mod 25. Now 2 to the power 1 is a 2. 2 times 3, it gives us a 6. 7 to the power 6 gives us 117. 649. So we want to check if 117649 is congruent to -1 mod 25. To check if it is congruent, we said that A is congruent to B mod M if M divides A minus B. So in this case, we are checking if 25 divides 117649 minus -1. Minus 1 gives us a plus there, so we'll be checking if 25 divides 117650, of which in this case we see that 25 does divide 117650. So we have this condition satisfied, and if it is satisfied there, we'll be saying that this linear congruence there is also satisfied. So if it is satisfied, we have satisfied this condition here. And if we have satisfied that condition, we are saying that 25 has passed Miller's test base 7. So we can go on and conclude that 25 is a strong pseudoprime base 7.